Alrighty, so I'm going to show you how to derive the identities that we have. Now everything follows from the angle sum formula, so let's get those first. There's a geometric way to do that. So what I would do first is draw a right triangle down here. Okay. And label that A. Okay. Sorry about the focus, I don't really know how to change that. For some reason that fixes it. Okay, and then you make this a right angle, and then you're going to make another triangle. Okay, I think putting my hand there messes it up. Then you're just going to kind of make a box out of this. Okay, so this is 90 minus A, so this is 180 minus 90, which is 90 minus 90 minus A, so this is A. And this is 90 minus A, this is 90 minus B, so this is 180 minus all that, so this is A plus B. Alright, and these are all right angles. So this is 1, we can scale that, so whatever, blow it up, shrink it, so that that's 1. Then sine of this is opposite over this over 1, so this is sine B. And then this is cosine B. Sine of this is this over cosine B, so this is sine A cosine B. So this will be sine A, or this will be cosine A, because it's adjacent. Cosine A cosine B. Okay, here sine of A is opposite over sine B, so this is sine A sine B. This will be cosine A sine B. And then over here, opposite is here, so this is the sine of A plus B. And this is the cosine of A plus B. Okay, from this diagram, you get that the sine of A plus B, this side here, is equal to that plus that. So we get sine A cosine B, the bottom thing, plus cosine A sine B. Alright, so this is the angle sum formula. For sine. Cosine, you get this plus this equals this, so cosine is that minus that. So cosine of A plus B is this one, cosine A cosine B, minus this one. Okay. To get the angle difference formulas, what we do is we make B to be negative in both of these, and then use the fact that okay, what we're going to do is say that now that we have those, we can do sine of A minus B can be written as the sine of A plus negative B. Okay, and then apply that formula. It'll be the sine of the A, the first thing, cosine of the second thing, cosine of the first thing, sine of the second thing. Alright, and now we use the fact that cosine is an even function, so that's the same as this. Sine is negative, or sine is an odd function, so the negative will come out. So this is the difference formula for sine. Difference formula for cosine. Do the same kind of thing. Apply this formula. Cosine of the first, cosine of the second, minus sine of the first, sine of the second. Okay. I'm talking to my phone.
Oh, gotcha.
Making a video.
Oh, sorry.
That's alright. Okay, so again, cosine is even, so that one is just cosine B. Sine is odd, so this negative comes out and becomes a sum. So that's how you derive the angle difference formulas. Okay. So now we have 4 formulas: angle sum and angle difference. These are angle differences. Formulas. Okay. These two here. This is this, and this is this. Now that we have an angle sum formula for sine and cosine, we can find the angle sum formula for tangent. Tangent of A plus B is sine of A plus B over cosine of A plus B. And we just expand those like we did up there. That's sine A cosine B plus cosine A sine B over cosine A cosine B minus sine A sine B. Alright, I'm just applying these two things and making their ratio. Alright, now that's one way of doing it, but we want it in terms of tangent. That would be nice. Okay, so what we do is I'd like to turn this into a tangent, so I need a sine over a cosine to get a tangent. So I need to have a denominator on this with a cosine A, and I need to get rid of this, so I also need cosine B in the denominator. So that is what we do. We send in the inverse cosines, the reciprocal cosines, to make this work. If I multiply the top by that, I also have to multiply the bottom by that, and then this makes everything work. Okay. So that gives me sine A cosine B over cosine A cosine B. Given this that denominator, now the other one also gets that denominator. And so do these ones. Everything has this denominator. Alright, now let's see what happens. These cancel multiplicatively. These cancel multiplicatively. This entire thing cancels multiplicatively, but that doesn't mean it's 0, it means it's 1. And then these, nothing cancels, but look, this here is a tangent of A. This is the tangent of B. This is tangent of A. This is tangent of B. So let's just write that. We get tangent A plus times 1, and then 1 times tangent B. Then this is a 1 minus tangent A tangent B. That is how you would derive the angle sum formula for tangent. Now remember, tangent is an odd function, so if we want a difference formula, we'll make this a negative B. This one will change, this will change sign, and so will this. So we also from that get that tangent of A minus B is tangent A minus tangent B. Just using the fact that it's an odd function, changing the sign on B, which changes those signs. Okay, so now we have sum and difference formulas for the three main trig functions. So, oops, I made it mad. Alright, so what do we want to do now? We can use the sum formulas to get double angle formulas. Okay, so sine of 2A, double an angle. Let's make it a different symbol now. Oops. Sine of 2 theta, let's say. Why do you do that? Sine of theta plus theta, right? That's 2 theta. Then we use the sine of a sum formula. That's sine of the first cosine of the second plus cosine of the first sine of the second. Okay, but these are the same thing. So that's 2 sine cosine. That's your angle. That's your double angle formula for sine. Do this something similar here for cosine. This is cosine of the first, cosine of the second, minus sine of the first, sine of the second. So that's cosine squared minus sine squared. Now, because of the Pythagorean identities, you can rewrite this in different forms. You can replace the sine squared with 1 minus cosine, and you could write it like this. Or you could replace the cosine with 1 minus sine, and then you would get 1 minus 2 sine squared. So there are 3 ways of writing cosine of a double angle. Alright. Depending on what you want to do. Tangent of a double angle, let's see what that is. Okay. That is tangent of the first plus tangent of the second over 1 minus tangent of the first tangent of the second. So that is 2 tangent theta over 1 minus tangent squared theta. Alright, there's your double angle formula for tangent. Alright, so the last thing we really need to worry about are the half angle formulas, and we use these double angle formulas to get them. Specifically, we use the cosine. These 2 versions of that to get it. So we have that 2 cosine squared theta minus 1 equals cosine of 2 theta. Solving for cosine gives you, if I make theta to be just theta over 2, right? It's true for anything, so let's use a different variable, but this gives us the 2 cosine squared of x over 2 minus 1 equals cosine of x, right? If I put in x over 2 in for theta, that's what you get. So solving for cosine of x over 2, it's cosine x plus 1, and then divided by 2, and then you take square root. Okay. Similarly, using this thing being cosine over 2, we have 1 minus 2 sine squared theta equals cosine over 2. Solve that for if you put an x over 2 in, sine squared of x over 2 equals cosine x. Doubling both. Here, you double it here. So, solving for sine. This is supposed to be a 1. Okay, you'd end up subtracting and dividing by a negative, so it would be plus or minus 1 minus cosine x over 2. Okay, to get the tangent of x over 2, you could just straight up take the reciprocal of sine over cosine. This is not a square anymore. Okay, so you would have this over that, so it would just be this divided by that is like the reciprocal, because these are both positive here. You can put them under the root. It's 1 minus cosine over 1 plus cosine over 2. Okay, I just took this and divided by that. Alternatively, we could say this is sine of that. Well, this is what I did, right? I just literally put this divided by that, but if you didn't want to, you could have just done this. Okay, so this is 2 sine cosine. That's the double angle formula, so that's just sine. And here we have 2 cosine squared of x over 2. We can subtract 1 and add 1. So this thing is now the double angle for cosine. So it's sine x over cosine x plus 1. That's another way of writing tangent. And then if you multiply by the conjugate of that, you'd end up with, so this is one way of writing it. You could also multiply by the conjugate of that thing down there if you wanted to. And you'd end up getting sine x times cosine x minus 1 over cosine squared x minus 1, which is, this is negative sine squared. So one of them would cancel, The negative flips that. It's 1 minus cosine x over sine. That is another way of doing it. So that's how you derive all the formulas.